showing? Abi?
Yes.
Okay, just one minute. So, Mike, this is the video on the measurement of heat energy and specific heat and thermal capacity of the body. So, I'm preparing for specific heat capacity. I'm preparing this video on specific heat capacity and thermal capacity of your body. Alright? So, the first thing that you need to know is this. Heat is a form of energy called thermal energy. Alright? It is a form of energy called thermal energy, and most times it flows from one body to the other as a result of temperature difference. Alright, for instance, if you put your spoon, alright, if you put it inside a cup of coffee or a cup of tea, right, and your spoon is metallic, alright, and it is cold, alright, but your cup of coffee, because of the tea, is very, very hot. You will observe that if you put the spoon inside your cup of coffee, with time you observe that when you bring out the spoon, it is hot already. Alright, so that is that utibuno already. So what happened? There was a transfer of heat energy from the hot cup of coffee to your spoon. That is why your spoon is hot. Alright, all of them as a result of the transfer of heat energy from one body to the other. And it is said most times that heat is being transferred from a region of very high or hot temperature to a region of very low temperature. Alright, so that's that. Then I'm sure you know that since heat is a form of energy, it can be used to do work and could also be transformed from one form to another. Heat is a form of energy, and every form of energy can be used to do work and be transformed from one form of energy to another. For instance, you can convert heat energy to electrical energy and oil. Alright, so and then that's that. And then the unit of energy is joule. The unit of energy is joule. Unit of energy, unit of heat energy, alright, is joule. It's joule. Alright, it's joule. So you represent joule with capital letter J. Alright, so then now I want to emphasize on this, that the addition of heat to a body causes the temperature to rise. Alright, the addition of heat energy to a body causes the temperature of the body to rise. I was trying to tell you the other time that when you put the spoon, the spoon was not hot before, you put it inside the hot cup of coffee, with time you observe that there's a transfer of heat from the hot cup of coffee to your spoon. Your spoon was not hot before, but with time you just observe that you can't pick up the spoon. It's very, very hot this time around. Alright, same thing with when you use your spoon to stir your soup on the pot while you are cooking. You observe that with time, because of the transference of heat energy from your gas cooker, alright, you just observe that your spoon that you are using to finish roll up is as a result of transfer of heat energy from what? From your pot of soup, from the gas to the pot of soup, then to your spoon. Alright, so I want to quickly differentiate between specific heat capacity and heat and thermal capacity. Alright, so I'll just use this. It has long been discovered that the quantity of heat received by a body, alright, it is discovered that the quantity of heat, alright, that is transferred into a body is given by this formula. Quantity of heat Q, alright, this is the quantity of heat, is said to be directly proportional to the mass of the body, alright, and the change in temperature. So this is your mass, alright, which could be in kilogram or gram. Then you convert it back to kilogram. This is your change in temperature. Your change in temperature. This is your change in temperature, alright? And you know your change in temperature is your final temperature minus your lower temperature. So let me break it down for you. So this formula becomes Q, which is the quantity of heat energy most times in joule is equal to, you're going to change your proportionality sign. You change it to equals to, so once you change it to equals to, there is an introduction of a constant k. All right, k, then m, then this change in theta. All right, so this constant k changes automatically to specific heat capacity, C. So that is why your formula at the end of the day will turn to Q, all right, equals to, this K will be C, and this M is here, your mass, and then times your change in temperature, theta. All right, your change in temperature. So I want to rub it off. I hope you can see it very well. Can you see it clearly from that side? All right, you can see all of this side. All right, good. So this is your Q equals to MC change in theta. So the formula becomes Q equals to M, all right, times C times the change in theta. And I told you this is the quantity of heat energy, all right, transferred into a body. This is the mass of the body. All right, it's either in kilogram or in gram. If it's in gram, you convert it to kilogram. All right, this is your specific heat capacity now. The constant was changed to specific heat capacity, and this is your change of temperature. In temperature, this change in temperature could also be Q equals to MC. Now your theta 2 minus theta 1. In some other textbook, you might see it as T2 minus T1. It still means the same thing. So theta 2 means final temperature, and then your theta 1 means initial temperature. All right. Now, what this means is that if you were to put that, I was trying to use the spoon to give an illustration. If you were to put your soup, your spoon that you are using to stir your soup inside your pot of soup, all right, and that pot of soup is on a gas, an electric gas cooker, all right, with time, spoon need a particular initial temperature before. Your spoon was having a particular initial temperature before. Let's say the temperature of your spoon, all right, that you're using to stir the soup is probably like 10 degrees Celsius, cold a bit and not that hot. And then when you put it inside, that's your initial temperature. Your initial temperature was 10 degrees Celsius, or you can also say 10 degree Kelvin. All right. Now, if you put whatever it is they give you, all right, of course you can convert your degree Celsius to Kelvin, which is going to be the addition of, I guess, 273 plus this one, and then you get your answer, all right, which becomes 283 Kelvin. But this is what I'm saying. Or I was trying to say that you put your, let's say your final temperature, your initial temperature was 10 degrees Celsius, and you put it inside the pot of soup. With time, you observe that the soup becomes very, very hot. So the temperature might change from 10 degrees Celsius to maybe 20 degrees Celsius or 50 degrees Celsius. So let's assume it's going to be 50 degrees Celsius. That means that your final temperature for this spoon is going to be 50 degrees Celsius. So this one is going to be 50 degrees Celsius. All right. So I repeat again, the unit of this one is joule, the unit of this one is kilogram, the unit of this one is change in temperature. It's more like, so if you have temperature minus temperature, it's going to give you temperature. Like if you do 50 degrees Celsius minus 10 degrees Celsius, it's going to give you 40 degrees Celsius, which is still temperature. All right. So then, let's try to see the result of the formula to see what the unit of specific heat capacity is going to give you. Then I will later give you the definition of specific heat capacity. So it becomes that it's going to be, just let's try to manage this side. All right. So it becomes Q equals to MC change in theta. All right. Your Q is joule. The unit of your quantity of energy is joule. The unit of your mass is kilogram. This is the unit. We're looking for the unit of this C. All right. The change in temperature is Kelvin. All right. It's Kelvin. We're considering Kelvin now. All right. So if you make this one set of the formula, you have to divide by kg by k. So by kg by k. So this cancels this. This cancels this. This cancels this. So you have your C equals to your specific capacity equals to joule divided by kilogram Kelvin, which is still the same thing as joule kg minus 1. Excuse me. kg minus 1, alright, kg minus 1, k minus 1. If you apply your indices, this one becomes minus 1, k minus 1. So this is the unit of specific heat capacity. So now let me define specific heat capacity. It is said that specific heat capacity is the quantity of heat. Alright, the specific heat capacity is the quantity of specific heat capacity of a substance. It's the quantity of heat energy required to raise the temperature of 1 unit mass which is 1 kilogram of a substance through a degree rise in temperature, that is 1 degree Celsius or 1 Kelvin. So the specific heat capacity of a substance, alright, is the quantity of heat, alright, is the quantity of heat energy, alright, required or that you need to raise, alright, is the quantity of heat energy that you need to put into a substance to raise the temperature of 1 kilogram. Now look at it. 1 kilogram is the same thing as a unit mass, alright, of a unit mass. It's supposed to be A here. A unit mass, 1 kilogram of a substance through a degree rise in temperature, that is 1 degree Celsius or 1 Kelvin. Alright, so this concept is actually simple. The specific heat capacity is more like the let's say this is a substance, all right. For you to get, let's assume the whole of this mass is 5 kilogram. Now you now cut off 1 kilogram out of everything here, all right. Let's say from here to here is your 1 kilogram. Now it's the quantity of heat energy required, or the amount of heat energy required for you to increase the temperature of this particular part of this pen, all right, which is 1 kilogram, by 1 degree rise in 1 degree Celsius rise in temperature or 1 Kelvin rise in temperature, is what we call specific heat capacity. All right, and every substance has their own respective specific heat capacity. For instance, the human body has its own specific heat capacity. This marker, for example, has its own specific heat capacity. Water has its own specific heat capacity. Every substance in this world, wood, every metal, every form of metal, every substance has their own respective specific heat capacity. But it is said that specific heat capacity of water is, when you see SHC, it means specific heat capacity. It's just like a short form of specific heat capacity. So when you see all right, that's that. So specific heat capacity of water is 4,200 joule, all right, joule per kilogram per Kelvin, all right, or 4.2 joule per gram per kilogram. So this one is just simple, all right. You know, this is the unit of specific capacity that I put for you the other time in the previous video, or still on this video if it is edited at the end of the day. So it's just 4,200 joule, all right. Now divided by kilogram is 1,000, all right, gram, all right, then your K here. So this, at the end of the day, all right, we'll cancel all of this, you get 4.2. So you get 4.2 joule per gram per Kelvin. So that's it over there. All right. So I think that's that. So let me just give you the list of the specific capacity of different substances. The specific capacity of some substances. The first one is lead. The specific capacity of lead, LEAD, all right, is 130 joule kilogram per Kelvin. Specific capacity of lead as 130 here, 130 joule per kilogram per Kelvin, all right, 130 for lead. Lead is LEAD, all right, it's an element. Alright, next one is the specific capacity of mercury is 140. Specific capacity of brass is 380. The specific heat capacity of zinc is 380. The specific capacity of copper is 400 joule per kilogram per Kelvin. Specific capacity of iron is 450 joule per kilogram per Kelvin. Specific capacity of glass is 670 joule per kilogram per Kelvin. Specific capacity of ice is 2100 joule per kilogram per Kelvin. The specific heat capacity of methylated spirit is your spirit that you use to clean your wound, is 2400 joule per kilogram per Kelvin. The specific capacity of seawater is 3900 joule per kilogram per Kelvin. 3900 joule per kilogram per Kelvin. So the capacity of water is 4200 joule per kilogram per Kelvin. So the specific capacity of water is the highest. It has 4200 joule per kilogram per Kelvin. It means that you will need serious amount of energy, enormous amount of energy to raise just 1 kilogram, all right, just 1 degree Celsius of 1 kilogram, or to raise the temperature of 1 kilogram of a substance, of water, all right, by 1 degree Celsius. It means you're going to be needing 4200 joules of energy. All right, so that is that. So let's quickly go to solving an example on how to solve for specific capacity calculations.